Hello class, I've received multiple questions from you regarding the review exercise. I would like to thank everyone for your questions, and I've decided to create a video to guide you through your tutorial review exercise questions. So let's start. To guide you through your tutorial, we will discuss the null and alternative hypothesis, extract the information provided, and finally determine the distribution to use. So for the first question, the claim is that the connection will give a speed of at least 11 megabytes per second compared to wired connection, a sample of 105 computers. So this will be the N is 105. Using wireless connection shows that the mean is 11.7. So the hypothesis or the parameter that we are testing here would be the population mean, which is mu. The mean comes from the sample. This would be x bar 11.7, and the standard deviation also comes from the sample. That would be s 2.3. So the null and alternative, as we've previously discussed, would be mu of at least. At least would be greater or equals to 11 megabytes per second. Definitely the alternative would be less than 11 megabytes per second. And the distribution that we will be using would be the standard normal distribution. So the test statistics would be Z star. On to the next question. What are the clues given here? It is known that the weight of vehicle that can be raised by a jack is more than 100 kilograms. We have a random sample of 125 with a mean. So we are testing the mean, null and alternative, testing the mean. More than 100 kilograms, that would go to your alternative. And the null would be less or equals to 100. Random sample of 125. The sample mean is 102.2 kilograms, and this would be the sample standard deviation, 15.17 kilogram. Because the sample size is large, we will be using the standard normal distribution. So our test statistics would be Z star. So this question is a bit different. We are given the data, and the clue that is provided is the average is at most 3.5 minutes. So we have here the null and alternative. At most would be less or equals to 3.5 minutes. And the alternative would be greater than 3.5. The sample size is 10. And alpha is 0.05, but nothing else is provided except for the sample data. So from the sample data, you would calculate the sample mean and sample standard deviation. Okay, now the sample size is less than 30, so we have a small sample, and the population standard deviation is not provided, so we would definitely use the t-distribution in this case, and our test statistics would be t star. So class, what's the most important clue here? Average, which means the null and alternative would be testing the mu. The average is 1.2 years, and do this data support the statement that the researcher needs exactly 1.2 years? So the alternative would be not equals to 1.2 years. We have a sample size of 12 researchers. Nothing else is provided except for the alpha. So you again would have to calculate the sample mean and sample standard deviation. And what distribution would we use now? The sample size is small. Population standard deviation is not provided, so the t-distribution, correct, and our test statistics would be t star. Next question. Class, can you help me find the clues? Yes, average here. So our null and alternative test for the average, population average, and the true average is at least 2 years. So what is at least? Greater or equals to 2. What else is provided? A random sample of 18 calculators, where the sample mean is 1.84. Now, the next statement is quite important. If it can be presumed from experience, when we have the word presume from experience, this would be our population standard deviation. So this is sigma 0.17. Although the sample size is small, but because we have the value of sigma, we would be using the standard normal distribution. And so the test statistic would be Z star. The clue here would be the mean. The parameter we are interested in would be mu. Exceeds 40%. Although it is in percent, but because it is testing for the mean, the parameter is considered as mu. So exceeds would be greater than 14%. I simply write it as 14 and treat the percentage as the unit. So this would be less or equals to 14. They knew that the standard deviation was 0.42. Now, past experience, am I right? So past experience, this would be sigma 0.42. A random sample of 5 pints, so n would be 5, and the mean x bar would be 14.9. Although the sample size is small, because we have the value of the population standard deviation, we would choose to use the normal distribution, and our test statistics would be Z star. We have again in percentage, but nothing about the average or the mean is mentioned in this question. So in this question, we are testing for the proportion. The claim is 55% has graduated with a CGPA less than 3. This would be the success. The claim is 55%. Do you agree with the claim? So the alternative would be not equals to 0.55. What else is provided? A random sample of 437. And out of this, 154 graduated with CGPA less than 3. This is our success. So that would be our P hat, 154 out of 437. Definitely for your proportion question, we would be using the normal distribution. Look at the claim. At most, 30% of pumps require repairs within the first 5 years of operation. So for a random sample of 120 was selected, 47 would require repair. The success here would be pumps that require repairs, and we are testing for the proportion. So this is P, at most would be less or equals to 0.3. The alternative would be P greater than 0.3. And N is 120. P hat would be 47 out of 120. We are going to use the p-value approach, right? And because this is proportion, we would definitely use the normal distribution. For the p-value, your p-value would be the probability of Z greater than the test statistics. So you calculate the test statistics and write it out here. That's it. The clue for question number 9 would be the word average here. So the null and alternative would be testing the mu. The average that is acceptable would be 1000 pieces per hour. Based on the sample taken, can you verify whether the quality control engineer is true in mentioning the average? Okay, so if it's false, then mu is not equals to 1000. We are going to use the p-value method, right? Okay, sample size is 64, so we are definitely using the normal distribution. Mean and standard deviation, so x bar would be 1038 and S is 146. Let's calculate the p-value. Because this is a two-tailed test, now this would depend on your test statistics. If it's negative, I would take 2 times the probability of Z less than negative less than the test statistics, right? Now, if it's positive, I would take 2 times the probability of Z greater than the test statistics. And that's it. Again, the p-value method. The clue is the word mean. So null and alternative would be testing for mu. The mean breaking strength is 15 kilograms. Could you help the manufacturer to test his claim? So the alternative would be not equals to 15 kilograms. The standard deviation of 0.5. Now this is his claim, right? This would mean that the standard deviation is not the sample standard deviation but the population standard deviation, 0.5. To test the eligibility of the claim, a random sample, so n is equals to 50, which gives a mean of x bar would be 14.9. Can you help the manufacturer to test his claim? So sample size is large, sigma is provided. We are going to use the standard normal distribution. You would first calculate the test statistics, and then we are going to use the p-value method. So the p-value, because this is a two-tailed test, it depends on the test statistics. If it's negative, I would take 2 times the probability of Z less than the test statistic, which would be negative. Now, if the test statistics is positive, then I would take it as 2 times the probability of Z greater than the test statistics. So question 11 says repeat the test using the p-value approach. That means you would have to use the critical value method and also conduct the test again using the p-value method. So you're going to do this twice. And the clue would be the word average here. So the null alternative test for mu at least it's greater or equals to 32.6. Less than 32.6. A random sample of 60 workers, so we're definitely using the normal distribution. You would calculate the test statistics here, the average, so x bar 33.8. With the standard deviations, that would be sample standard deviation 6.1 minutes. What can you conclude based on the sample? Okay, so now you will first conduct the hypothesis testing using the traditional method, and next when you're going to use the p-value method, so much easier than the traditional critical value method, you would write it as the probability of the distribution Z distribution. Would just simply copy the alternative, copy down the value of the test statistics. And now because this is a one-tailed test, it doesn't matter whether the value is negative or positive. Simply copy down the value here. So this question also asks us to repeat by using the p-value method. So you'll be using the traditional method and then repeat using the p-value approach. So the word mean is here. That's our clue. Now an alternative test for the mu. And the claim is it is at most 34. So at most would be less or equals to 34. And the alternative would be greater than 34. Random sample of 36. So this would definitely be a normal distribution question. So you would calculate the test statistics. Sample mean is 34.66 and sample standard deviation is 2.14. And when we are using the p-value approach, you simply take the probability of z, copy down the greater than here, and straight away copy down the test statistics here. Okay class, thank you so much for going through the review exercises with me. I hope you had fun as much as you gain new knowledge and practice for your midterm. I'll see you in the next video.